So the first thing I'm going to go over are some really simple things that you can do in R to get an overview of your data when you first put it in. So I would use most of these in these next functions that I'm going to show to when I first put my data into R and to see what's there. So this is called the table function. So any SAS users, it would be similar to a proc freq. So this gives us a frequency table of the different groups in our data set. So one I'm going to be using here is world.df. So it has a lot of world metrics, literacy rates, population growth, HIV rates for a whole bunch of different countries. I got it from Gapminder, and it has a repository of a whole bunch of different metrics from countries all around the world. So I'm going to get started with that. So here, it's a very simple function. You just put within that table function your data frame that you want to look at, and then the variable you want to find frequencies on. So in this case, pop growth rating is something that I created based on the population growth, and I'll show you that in a second. I labeled them either decreasing, high growth, low growth, or medium growth. So you're seeing here that, and this is going back to last class, that these are not listed they're listed in alphabetical order. Say you wanted to change this order for some reason, that's what you would use a factor variable for, just FYI. So if you wanted them in any particular order. So with the table function, you can also do look at the frequencies for two different variables. So we're looking at world.df, the population growth rating that we just saw up here, as well as the development variable. So there is a development metric that goes from 0 to 100, and I marked anything that was above 50 as developed and anything under 50 as underdeveloped. So that's where this is coming from. You're also seeing a pattern here. So high population growth seems to be correlated with underdeveloped countries. And then you can see elsewhere that there are less countries. So I'm going to go in and show you guys this in R. All right. So we're going to load world.df. Also, I had showed you how to do this if you can't remember or need more practice about this. First, I want you to load the library dplyr, and you'll need to install it using install packages if necessary. I did provide the link where I got this data. So let's load it in, world.df. I'm going to open it so you guys can see more about what it looks like. It's a really big data set. When I was preparing data for this particular class, I just wanted to kind of get it all in one fell swoop, and then we can look at a whole bunch of different metrics all at the same time. So I'll be using this for classes, a lot of them going forward, especially the next class. When we're going over indexing, we'll be going over missing data as well, and you'll see in here a lot of the different sources have different data collected for each country. So there's a lot of missing data in this one. So this will definitely be the indexing data set we'll go over. So you're seeing this population growth variable here. I gave it a rating. So anything that was negative, I marked as decreasing. Anything that was below, well, I found of their remaining values, I found the 33rd percentile and the 66th percentile. So basically, at that point, I divided it into 3 groups once these decreasing values were gone. There's another interesting one here, corruption percent score. So this is a little counterintuitive, but the way that they do it, the higher the number, the less of perceived corruption there is in that particular country. And the lower it is, the more perceived corruption from the individuals in that country. So you can see there's a lot of other things in here, HIV prevalence, life expectancy, development. And there's education in here as well. So I just wanted to give you a look at that. So say you want to look at the top of your data. This will show you the first 6 rows unless you specify something different. So showing the head, this is going to show us the first 6 rows of our data here. And say we wanted to see more than 6 rows or less, say you can do, I believe it's n equals, let's say 8 length. It will show then 8 rows, for instance. So that's just a little trick. You'll notice that base R functions just generally have some glitches like this. It's designed this way, but if you're excuse me, I have a cold. If your data has a lot of columns, it's going to wrap down and print on multiple columns, or on multiple rows, I mean. So there's actually, and I didn't originally put this in the slides, but there's a way to get that same information, a bird's eye view of your data without this formatting issue. So I believe it's part of dplyr, but it's called the glimpse function. And then we can use that and you'll see the difference. So it puts everything all in one line, and then it stops when you run out of room, basically. So this might be a better one to use, although head and tail still, I use it as well. So I use both of them. So that gives you an idea of that. So now we go down to our tables. Okay. I'm going to skip this for just a minute. We're going to go down to our population growth rating. As we saw in the slides, we had this here. And then we also looked at the development, and we're seeing that here on these different countries. So one thing that I would look at seeing this, that I probably, that we have that relationship there. So also you'll see that there are more underdeveloped countries than developed countries. So the way I categorize that might not have been the most accurate. So I would go back and take a look at that. So that is how we would use the table function. So the next thing I'm going to go over is length and unique. This is really useful when you're cleaning data in order to check if you did something accurately or not. So it's also really useful to get a bird's eye view of your different variables. So here I'm going to give an example. So in this case, it's going to show the unique values in world.df and within the variable of corruption percentage score. So if I do this, it will print all of the unique values in that corruption percentage score. So you'll see here that it does show the NA values here, and NA again is missing. We'll go over more about missing values in the next class, the next programming class at least. So another thing that you can do is look at the length of the entire variable. We're seeing that 225 here. It does include missing data in this number, but we're seeing that that makes sense because there are 225 rows in our data set. All right. So something that this is usually something I use when I'm creating new variables with if-else statements, or just manipulating data. This is really useful to make sure you didn't lose anything. So it's basically combining the uses of these two. So I often use the unique values within the length function. So basically this is combining two functions to tell you how many unique values are in your data set. So length unique, it's showing me that there's 70 unique values in this data. So there are probably some duplicates in this score. So that's the information that it gives you there. I believe it does count the NA value as a unique value. So that one NA since it's a unique row value in your data set. So the other thing that I often use is the number of columns and the number of rows. So number of columns will return 32. You can see that information here. It'll also, number of rows will return 225. So we can see that information here. So I will go back into our PowerPoint. That's what is showed here, just exactly what I just showed you. These are very simple for the most part. You're just putting your data frame in all of these functions, our $, and then whatever variable you want to look at in this case. With the exception of the head and tail, we're looking at the entire data set here. So these are just some really useful things to do when we are trying to get an idea of our data. Are there any questions before I move on? I'll go back to the chat and see if there's anything. Yeah, so the length and unique. So unique would mean the same thing in this case as distinct. Yes, that would be another way to put it.